Hi, in this particular video we're going to be looking at the sample papers for the foundation tier from Edexcel, and it's paper 3, the calculator paper. If you follow the link below in the description, you'll be able to download this paper and have a go at each of the questions for yourself. Okay, so let's move on then to question number 1. And in question number 1 we've got write 2148, correct the nearest 100. Okay, so correct the nearest 100 means that you look at the 100s column, which is a 1. That's going to stay exactly the same. Because the number after that is a 4, so I'm going to leave that as 2100. Okay, on to the next bit. So we've got simplify 8x minus 3x plus 2x. Well, all we're going to do with that is just gather up these like terms. So 8 minus 3x is 5x plus 2x. Well, that's going to give you 7x. Okay, let's move on to the last one on question 2, which is 2b. A little bit trickier. We've got 4y times 2y. So if we look at the numbers first, we've got 4 times 2, which is 8. And then we've got y times y, which is y squared. Okay, hope that's all right for you. Let's move on then to question number 3. There's a little bit of calculation involved in these ones. So the first thing is it tells us there's 6,760 people at a rugby match. Some of them are men, some of them are women. So actually, let's look at then the number of adults that are actually at the rugby match. And you'll notice before in previous videos, what I'm trying to encourage you to do is to look at each of the questions a bit at a time. Okay, so let's just get a little bit of information from this. What we're saying is that if there were 3, 8, 7, 9 men and 1, 2, 4, 1 women, it means in total at the rugby match there were 5,120 adults. Okay, which means that if there were 6,760 people altogether, if we take away the number of adults, it means there was 1,640 children. Now you appreciate that I'm actually showing the calculation here, but if you use your calculators, you'll be able to come up with hopefully the same numbers. Alrighty, and then it says 1/4 of the children are girls. Well, that basically means that 3/4 of them then must be boys. So if we want to work out how many boys there are at the rugby match, it's going to be 3/4 of 1,640. If you pop that into your calculator, you're going to get 1,230. So actually there are 1,230 boys at the rugby match. Okay, hope that's all right for you. I am showing the calculations, but as I say, if you do use your calculator, that's fine, but do show the examiner the calculation that you're actually performing. So it is useful to kind of write these down anyway, even if you don't work them out. Okay, let's move on then to question number 4. And in question number 4 we've got this graph, and we're being asked to initially at least write down the coordinates of point A. Okay, well here's point A, and the coordinates go along the corridor 3 and up the stairs 5. So the coordinates of that will be 3, 5. Okay, and then part B is on the grid, mark with a cross the point 1, 2. Well, exactly the same way, we go along the corridor 1, go up the stairs to 2, so that's going to be this point here. Okay, and we're going to label that D. Okay, and then finally part C is on the grid, mark with a cross a point E, so that the quadrilateral ABCE is a kite. All right, well let's just have a look at that. So just be a little bit careful about this. Quadrilateral just means a 4-sided shape. That's all it means, okay? And you're going to come across these sorts of words, unfortunately. It just means a 4-sided shape. And a kite is going to look a little bit like this. So what I'm going to do is put a point in there and join that up like that. I'm sorry about my lines, but I'm not using a ruler at the moment, but hopefully it'll give you some idea. So in other words, this is the cross E. Okay, it's that point there. And that is a kite shape. And the thing about a kite shape is you've got to remember that it's got a central line of symmetry. It's got a single line of symmetry that goes between the two there. Okay, hope that's all right. Let's move on then to question number 5. This is one where you do need to make sure that you read it thoroughly through and make sure you follow all of the information that you've got. So Pfizer goes out and she buys one magazine costing £2.30 and one paper costing 92p. So before we go any further, let's just figure out how much she's spent. So again, at this point, I'm only dealing with that and I'm saying, well, that's going to be £2.30 plus 92p. And if I put that either into my calculator or work it out, she's gone out and she's spent £3.22. And then it tells us that she bought not just the magazine and the paper, but also 2 bars of chocolate, which happen to be identical bars of chocolate. So that's going to be plus 2 bars, okay, of chocolate. Okay. Alrighty, so 2 bars of chocolate, which means that if she then paid with a £5 note and she got 40p change, it means that she actually spent £4.60. Okay, so this bit here means that it's going to be £4.60 that she's actually spent. So £4.60 less the cost of the newspaper and the magazine is going to give us £1.38, which is the amount that she spent on the 2 bars of chocolate. Okay, hope that's all right for you. So therefore, if we then get £1.38 and divide by 2, that is going to mean that each bar of chocolate must be 69p. Okay, so it'd be 69p for 1 bar of chocolate. Okay, so let's move on then to question number 5. And in question number 5, we've got a little bit more kind of handling data, as it's called, which is where you've got, in this particular case, a bar chart. And what we're going to do is just take a little bit of information from this bar chart. And it says, what fraction of the students in class 11A, so this deals with 11A, are girls. Okay, so we've got to differentiate between boys and girls and also the total amount of students that are in the particular class. So if we look at this, we've got 14 boys, okay, which is this point here, and then girls is actually 15 girls. So in actual fact, there are 29 students in that particular case, of which 15 of them are girls. So the way that we write this is we say it's 15 out of 29, which is the fraction of students in the class 11A which are girls. So that would be 15 out of 29. Okay, and then Shola says that there are more boys than girls in year 11. So is she correct? Well, basically, we've got to work out how many boys there are and how many girls there are. So really, it's a case of going back to the bar chart and figuring out all the boys. Okay, so boys is going to equal, in 11A, you've got 14, which we've already worked out. In 11B, we've got 12, then we've got 8, then we've got 4. So actually, we've got 38 boys in each of the year groups. Okay, and then if we look at girls, well, we're going to do the same exercise. We've already said that in 11A there's 15 girls, so there's then 11 plus 7 plus 5. Okay, if you add that all up, that's also 38. So actually, Shola is incorrect. It's the same number, so she is incorrect. Okay, and if I write in here, same number. Alrighty. Okay, hope that's all right for you. Let's move on then to part C of this particular paper, or this particular question, which then deals again with handling data. In this particular case, it's a rather complicated looking pie chart, and actually there's only one question worth 1 mark for this particular pie chart, and it's really just asking you it gives you all the information about the 76 students in the same 4 Year 11 classes. And then says, Tolu says, it is more difficult to find out the number of students in each class from the pie chart than from the bar chart. Well, yeah, it is. Of course it is. It's really quite difficult to read. So in this particular case, yes, it is. Okay. And the reason you might want to give is because you might need to measure and calculate. If I put you need to measure each angle and calculate the number in each group. Okay, so something like that would be perfectly fine, whereas you've actually got the information on a bar chart and it's much, much easier to read. Pie charts do have their place and they are very, very useful, but generally they're there for comparison purposes as opposed to information purposes. Okay, so let's move on then to question number 7. And in question number 7, we've got an input machine. Okay, these are becoming quite popular actually. I seem to see these quite a lot on exam papers. And it says work out the output when the input is 4. So what we're actually saying is that we're putting in 4 into there. And then what we're going to do is we're going to multiply it by 3 and then we're going to take 4 away. So if we do that, we've got 4 times 3, which equals 12. And then we've got 12 minus 3, which equals 8. So therefore, with this particular input-output machine, we're going to have an output of 8. And then we've got to work backwards a little bit, where it says work out the input when the output is 11. So if we say, well, actually, we've got 11 there. So if we've taken 4 away, then what I'm going to do is I'm going to add 4. So it's going to be 11 plus 4, which equals 15. And then rather than multiply by 3, I'm going to divide by 3. So I'm going to do the opposite each time, which means that the input must have been 5. And if you want to check that, you could just work it through. So 5 times 3 is 15, minus 4 is going to give you an output of 11. Okay, so that's going to give you an input of 5. And then it says, show that there is a value of the input for which the input and the output have the same value. All right. Okay, so this, unfortunately, it's quite difficult English to kind of work through. But what we're basically saying is that we have a number that goes in to the machine. And I'm going to call it, so if my input is going to be X. So what actually happens that X? Well, what we do is we multiply it by 3 and then we minus 4 away from it. And according to this information, we get the same number out again. So we start with X, we multiply it by 3, we take 4 away, and we get X out again. And then really it's just a case of solving that equation. So what I'm going to do is I'm going to take this minus 4 over to the other side, and I'm going to end up with 3x equals x plus 4. And then I'm going to take this x and move it to this side. So I'm going to end up with 2x equals 4. And if I then divide through by 2, I get x equals 2. Okay, now if you want to check that, let's just look at that input again. You need to have the paper in front of you, otherwise I'm going to be moving it up and down on the screen. But if you've got the paper in front of you, you then put an input of 2. I'm going to multiply it by 3. Well, that's going to give me 6. And then I'm going to subtract 4 away from it. So that's going to give me 2 as an output. So my input and my output are the same. Now, unfortunately, with this particular question, it's a little bit tricky to see the English. So I hope that's been all right for you. Okay, you might want to just play around with that a little bit and maybe try some other numbers. Okay, so I'm conscious of the time. I'm going to aim for about 20 to 30 minutes on this particular video. So let's move on then to question number 8. And question number 8 is a an approximation. Okay, so be careful about these ones because we're looking for approximations, so it's just an estimation. So effectively what we're saying is we've got 1 yard. Okay, it's a very old English measurement actually, and that 1 yard is equal to 36 inches. Okay, so if it's 36 inches and 10 centimeters an approximation for 4 inches, okay, so what we're saying is that we've got this little bit in here which is the same as saying 4 inches, or if you like 10 centimeters. Okay, so what we can say is that there are 9 lots of 4 inches in 36 inches. So in other words, there's 9 of these, so this is times 9, and that's going to equal 36. Okay, so if you like, I can write that down as 4 inches, the number of 4 inches in 36 inches equals 9. Okay, so each 4 inch is going to be 10 centimeters, and that means that that's going to be also multiplied by 9, which is going to give you 90 centimeters. Okay, so if there are 90 centimeters in 1 yard, remember we're talking about 1 yard here, then in 2 yards there's going to be 180 centimeters. So if I put in here 1, that's the equivalent to 1 yard, and then this is 2 yards. Okay, I hope that's all right for you. Do please check through these sorts of questions, maybe practice them a little bit, because sometimes they do take a little bit of working through. All right, so next one is a calculator question, really. 234% of 150. You could work it out as a non-calculator, but would take a little bit of time. So as a percent, as you know, percent really means out of 100. So if I use the fraction key on my calculator, I can write that as 234 out of 100 multiplied by 150, and when I press the equals key, I should get 351. So the answer to this particular question would be 351. Okay, let's work on then to question number 10. And in question number 10, again, this is another fairly popular one where they're asking us to compare numbers and write them out in order of size. So there's a couple of different methods of doing this. In this particular one, what I would be inclined to do is work them all out as decimals. Now, it doesn't necessarily mean that you have to, but because you've got a calculator, if you key in these fractions into the calculator, now on my calculator, I press something called the SD key, and what it does is it tells me that 3/7 is the same as 0.428571, and that's actually recurring. And it also tells me that 7/16 is the same as 0.4375. Okay, and a percentage here, well, that's the same as 0.438. Okay, so I've now got all of my fractions and percentages as decimals, so I can just simply write them out in order. And you can see here that 3/7 is going to be the smallest one. Now, don't be tempted just to write these decimals out. You need to actually write them out as they're given to you in the particular question, because that's what they've asked you to do. You would lose a mark, I think, if you just chose to write out the decimal equivalents. Okay, so hopefully that's all right for you. Do practice these sorts of questions because they seem to be fairly popular. Okay, as is the next one, here is a list of 5 numbers. Write down the prime number and write down the square number. Okay, well, a prime number is a number that's only divisible by itself and 1. So there's no number that will divide into the number 17. So if I look at, say, 15, I can divide that by 5 and 3. So that's not a prime number. So 17 is, so that's the prime number. And then the square number is a number where 2 of its factors are the same. So in this particular case, I can do 4 times 4, which is 16, and that's a square number. If I look again at, say, 14, well, 2 of its factors are 2 times 7, and neither of those are the same number. Okay, so 16 in this particular case is the square number. All right, hope that's okay. So we're on 20 minutes. I'm going to carry on a little bit further and maybe take this through to about 30 minutes, and hopefully we'll be able to get this whole paper done in a couple of videos. So let's move on then to question number 12. Question number 12, we've got a star shape. Okay, and it says it's made up a regular hexagon and, okay, this word, 6 congruent equilateral triangles. Well, equilateral triangles, you might remember from primary school, it's triangles where the sides and the angles are the same. Actually, each of the angles is 60 degrees and all of the sides are the same. Okay, congruent basically means it's one of those maths words, and it just means that they're the same. Okay, so each of these 6 equilateral triangles are all the same. Okay, and if you look at it here, that's the triangles, the 6 triangles that they're referring to. Okay, then it says the area of the star shape is 96 centimeters squared. Well, you kind of have to think about why they've given you that information, and that's because what we can do is, if we make all of this whole shape into equilateral triangles, what I've got then is actually 8 in total. I've got 6 in the middle, and then I've got I beg your pardon, I've got 12 equilateral triangles. So I've got 6 in the middle, then I've got 6 around the outside. So these 12 triangles are each equilateral, and they total up 96 centimeters squared. So if that is the case, then each of them, so each triangle, is going to be 96 divided by 12, which is going to be 8 centimeters squared. Okay, so we're saying that each of these is 8 centimeters squared, and it doesn't matter which one. So therefore, the area of the regular hexagon, so the hexagon is going to be 6 of these 8 centimeters equilateral triangles, which is going to be 48 centimeters squared. Okay, hope you followed that okay. It does take a little bit of working through, but generally when they start talking about things like congruency and equilateral triangles and all that sort of stuff, it just means then that you can use the grid to be able to make the shapes all the same. Okay, let's move on then to question number 13. And question number 13, we've got another word which you're going to come across from time to time. It's going to be this word quadrilateral. Okay, so it says that WXZY is a quadrilateral. Okay, well, quadrilateral is just one of those words. It just means a 4-sided shape. Okay, 4 sides. So what they're talking about is this shape here. Okay, so if it's a quadrilateral, then you need to maybe appreciate that all of the angles inside a quadrilateral add up to 360 degrees. Okay, so if they all add up to 360 degrees, it'll enable us to work out some of the internal angles, and we're going to be coming to that in part B. Okay, in part A1, however, we've got to work out the angle marked A. So the other thing you need to remember is that the angles on a straight line add up to 180 degrees. So this straight line here is 180 degrees. So to find the size of the angle marked A, all we do is we do 180 minus 147, and that will give us 33. So 33 degrees, and actually, as is with a lot of these type of questions, it'll then say give a reason for your answer, and the reason is that angles, okay, on a straight line are 180 degrees, or add up to 180 degrees. Okay, so then we mentioned before about having this quadrilateral where the internal angles add up to 360 degrees, and we're being asked to work out the angle ZWX. So let's just have a look at that. ZWX. Well, it's ZWX. So in other words, it's this one over here that we're being asked to work out. Okay, well, I would make a note, quadrilateral. Okay, so quadrilateral equals 360 degrees. Okay, and what it also tells us in the text is that this angle and this angle are the same. So in other words, actually this angle is the same as this angle. Okay, so let's just have a look at that for a minute. So if all of these angles, these 1, 2, 3, 4 angles add up to 360 degrees, then what we can do is we can say, well, let's just work out these two here. So that's going to be 145 plus 33. Well, that's going to give you 178. Okay, and then I'm going to take that 178 away from 360. So 360 take away 178 is going to give me 182 degrees. So in other words, this 182 degrees is shared between this angle and this angle. Okay, so if I want to work out the value of each of those angles, which are the same, I'm just going to divide them by 2. So 2 into 182 equals 91. So therefore, each of these angles, this one and this one, or this one and this one, are both 91 each. So the answer to my particular question is going to be 91 degrees. Okay, right, so I think what I'm going to do is stop there. That's actually 27 minutes into the video, and that's going to take us to the end of question 13. So we'll start again at question 14 in part 2. I hope you've benefited from this and you've had the opportunity to work through each of these questions. Please keep pausing the video, having a go at each of these questions and deciding for yourself whether you're okay with the solution. If you get any questions, please don't hesitate to add a comment below. I'll always come back to you, and I'll look forward to seeing you inside the next video.